Hey guys, so oops, I didn't even finish that integration of, well, that's pretty funny. Integration of a to the x here. So when we're when we're dealing with this, we won't have the special condition rule that we have for our a to the x taking the derivative. Basically, you're just going to have to have this formula at your disposal and keep working with it until you get used to it. So it's pretty self-explanatory where the integral of a to the x of dx is equal to 1 over the natural log of the base a times a to the x. And it basically comes from the idea of what we did with the special technique yesterday. So when you're dealing with like this one here, 3 to the 2x, which is like your second example that they have on the sheet, basically uh, you're dealing with this natural log of a. Now, don't forget that this 2 comes from that piece right here. You always have to take into account that piece. So that is literally the derivative of that. So if you want to say it, that'd be like u prime. Okay. So always, like if this was a u substitution, that would be u prime. So these extra numbers that come out in front are usually from what's in the exponent. That's why I wanted to draw your attention to this one. So when we're dealing with these, just follow this formula right here, guys. And this is, I think, worksheet 30. So you're just going to follow this formula here. Keep track of the fact that if there's a 2 to the x in here, that 2 is going to pop out on the bottom down here. So if you wanted to, you could put like x prime right there for this. Make sure there's an x prime right there. And then it doesn't change if it's from, I think in the example, they go from 0 to 3 of 3 to the 2x dx. And so that just basically means that you're going to take the integral of this, which is going to be 1 over 2 times the natural log of 3 times 3 to the 2x. And then you're going to plug that, you're going to evaluate that from 0 to 3. And so you would do your math where you do your upper minus your lower, and we'd get our answer at that piece. So again, it's the same exact stuff we've been doing, except we got to follow and use this formula right here, this basic derivative, integral formula that we have right here. I'm looking at the worksheet right now about different pieces here. Nothing stands out. Just watch out for, like I said, watch out for these guys here. So if you're given something like this right here, if you're given e to the 3x, don't forget that 3 is going to pop out as this 3 to the x is going to pop out as a 3 somewhere in the problem. Just little pieces like that. Like on number 4, I'm just kind of giving you guys a little bit of notes. Number 4, because it's 7 cosine of t, don't forget that this is going to end up becoming sine somehow of that particular piece. So just be careful with the u on top. That's our biggest piece that we want to deal with using this formula. There's so many different little ways to tackle these. Let me know if you guys need help. And that is kind of the setup for this one here. These are more of let's do them in class, and we'll help you guys out there.